Okay, continuing to work with mouse pigmentation, we've got one trait C that enables the mouse to have a color at all, and then another trait B that determines whether it's black or tan. And they give us another set of parents here. This parent is little c, big B, big B. Now, the B gene by itself says this mouse should produce black pigment, but that's overridden by this trait, which is the colorless one that says it doesn't produce pigment at all. It's an albino mouse. So it would produce black pigment, except this gene says don't make pigment, full stop. So this is a colorless or albino mouse. Albino crossed with, now this mouse has the color trait. It does produce pigment. And what color is that pigment? Black. So if we cross these, albino cross black, as usual, we want to know what gametes can come from each parent. And this one's very simple. The only C it has is the recessive C allele, and the only B it has is the dominant black allele. So that's all we're going to get from this parent. And this one is heterozygous for both traits, so we get to FOIL it to see the four combinations, which will be big C, big B, big C, little b, big B, and little c, little b. Again, that comes from first, outside, inside, last. If we say we're foiling one of these, that's what we mean. First is the first from each pair. Outside is the far left and far right. Inside is the middle two, little c, big B. And last means the last C with the last B, the recessive ones. So if we do a Punnett thing to see how these combine for possible offspring, we get little c, big B guaranteed from that parent, and then we get these. All right, so our combinations are going to be big C, little c, big B, big C, little c, big B here and little b here, always dominant first. Little c, big B, and little c, big B, little b. All right, so what do these actually look like? This one has the dominant color trait, so it does produce a color. What color is it? Black. Black is dominant over tan here. You could put colored black if you want to mention this trait, but I think either way is reasonably clear. Here we get colored black again. Different genotype, but the same look. Here we get colorless, which means we don't even have to look here. This pair tells us this mouse would produce black pigment if only it could, but this says no pigment for you. You are an albino mouse. You have white fur with no color to it. And colorless again. This again would have been a black mouse because of the dominant B, but once again doesn't happen because the albino trait overrides it. It's like you're trying to have red hair, but this trait says you're bald. Doesn't matter what your hair color would have been if you don't produce it in the first place. Same with pigment here. So, genotypic ratio, all these are different genotypes, so we'd have to say there's a 1/4 probability of each of these genotypes coming up, or you could say the ratio is 1 to 1 to 1 to 1 for each of these genotypes. And for phenotype, it's simpler. You just have 2 black to 2 albino, 2 black. Now there's something wrong with what I'm writing right now. If you've noticed that, good for you. Saying a ratio is 2 to 2 is like writing a fraction 2 over 2. You should reduce that. Divide both numbers by 2 and you can say the ratio is 1 to 1. As in for every 1 black mouse, you should get 1 albino mouse.